I decided that I would close up these capacitors with hot glue. So I plugged in my hot glue gun and I'm waiting for the head to heat up. And in a moment, once the glue is all hot and sticky, I'm going to spray a liberal amount of hot glue inside this can and then close it up. But before I do, I'm also going to spray some hot glue around the base of my capacitors so that they don't move about this much and they don't vibrate and all that. And it also provides for a little bit more insulation at the base. So the hot glue should prevent any sparks from flying. Although frankly I don't know what the exact insulation value is of hot glue. Still, it's better than air, I believe, in this case. Alrighty, I mounted or reassembled the capacitors. It's not extra super pretty, but it'll do. And well, at least I'm trying to preserve as much as I can the originality of the part, but it's kind of hard to make it look exactly the way it looked. Still, the point being that I managed to preserve more or less its original look. So now what I'm going to do is I'm going to mount back the capacitors like this, and I'm going to try to reconnect them properly. Okay, so that's what I'm going to do. I'm going to reconnect all the wires you see hanging loose now. I labeled them, just, you know, I didn't trust my own memory too much, although I took a lot of pictures. And then I'm going to reattach these replacement capacitors, a 200 microfarad and a 100 microfarad. And once this is done, then we'll continue with the rectifier. There was still an electrolytic hiding inside the chassis, and it's right there. This is a 50 microfarad, 12 volt electrolytic. Now I don't have 50 microfarad, but I do have 47 microfarad, something like this. It's not an actual one, but it will do. It's 47 microfarad, 16 volts. So I'm going to quickly replace this one as well. Now in the meantime, I'm waiting for the epoxy to set on my self-made rectifier bridge. I'll give it, oh, I don't know, an hour more to set, to cure, and then I'm going to mount it inside the chassis somewhere here. Alright, I disconnected the old selenium rectifier, which you see here, and I built my own little bridge rectifier with 4 1N4007 diodes. These diodes are all-purpose diodes. You can use them for all sorts of things, and one of those is, of course, building a small bridge rectifier. Now, the schematic, if you wish, of that little bridge rectifier is the one on the right. Okay, so there are two possibilities. Well, there are probably more, but I drew two possibilities, and I actually used this one. Okay, so the AC comes in on those two little pins you see here, and the positive of the bridge rectifier is the right pin here, and the negative is the left pin here. Okay, so you can build your own bridge rectifier with 4 diodes. It's really okay. I used a little piece of test PCB, but with a little bit of effort, I suppose you could even build one with just the 4 diodes and nothing else. But for convenience, I used a tiny bit of PCB. Okay, so that's for the bridge rectifier. Now, I'm going to attach the bridge rectifier somewhere here on this side. Okay, here, so right here somewhere next to the selenium rectifier, and I'm going to use double-sided tape, a tiny bit of double-sided tape, to stick it to this plastified wall, because this wall, well, maybe it's even plastic, but it might also be plastified metal. I can't tell really, and I don't want to scratch it or anything. So the bridge rectifier will be mounted something like this inside the TV chassis, and when I attached the bridge rectifier, the new one, I intend to reconnect all the parts, including all the PCBs, well, all the 2 external PCBs, or I should say the 2 unmounted PCBs, and I am going to give the TV a test shot, so to speak. I'm going to power it up and see whether it functions normally. Now, with a bit of luck, we'll find out whether it works or not without any trouble. I actually need to bend these tabs up, which I'm reluctant to do because, well, I've heard many times that these tabs have a tendency to break off. But if we want to go into the box, I need to bend them up. So that's exactly what I'll do. And I'll try to do it carefully. Now I'm just looking. Okay, I think it can be done. So here we go. Okay, that's one tab. Now I need a small screwdriver to lift this one up a bit and this one up a bit. Okay. So, okay. Right. Okay. Okay, all the tabs are up. So now let's see if I can slide down the box. Oh dear, it's not as easy as it looks. Okay. What is inside the box? I am really curious. I'm really curious to see what is inside of it. But I have to be a bit careful bending it up, because I can see already one problem, which is the anode wire. You see, the anode wire is blocking, so that is not going to be easy to open up. And believe it or not, from what I can see inside, it looks more like, I don't know, like two electrolytics perhaps, or maybe two coils. Now, heck, I don't know what's inside, so let's try to move it out, but I'm afraid of damaging the... Okay, so I'm not going to slide it out more. What I am going to do is there are two tiny little screws on top, so I'll see if I can undo the nut, perhaps, but I don't know. Okay. Well, at least one nut went relatively easily. Okay, here you go. I released one nut, so now the other one. Now let's do this one. I'm not so sure this one is moving. It's okay. No, it's not budging. So I'm not sure I should continue to try to undo it, because well, I really don't want to damage what's inside, but I can't actually tell. According to what's on the schematic, let's have a look. let's see now. No, this is not the right one. This is it. Okay, so according to the schematic, if you take a close look at it, you see here there are 3 tubes marked 1DK1, and these three tubes should be what's inside that little box. Well, you could say the high voltage cage, together with at least part of the high voltage coil. But I think it must be all inside that little box. So the high voltage coil must be something really tiny to fit together with those 3 tubes inside a tiny little box like this. So well, here's my conundrum. I can try to open the box up completely just to see what's inside. However, I hooked up the power supply transformer to my self-made, or I should say homemade, bridge rectifier, and I attached my multimeter to it. Now I seem to be getting a reading, DC voltage, let's say, but it's fluctuating a lot. Now the weird thing is that there's absolutely no current to speak of running through it. My variac is set to 0, and still I'm getting well, some sort of DC current. Now it could be that the meter is so sensitive that it is measuring something, yes, and that's why it's showing 7 volts, which frankly is incorrect. But okay, let's switch on the TV and see what happens. Okay, the voltage drops a little bit. So now let's turn up the variac a little bit, say to 50 volts. Now I should remind you that the transformer is a 220 volts rated transformer, okay? Alright, we're at 50 volts and the meter reads out 6.8. Okay, let's turn it up a bit more, say 100 volts. Alright, we're at about 110 volts, and the DC current is now, or voltage is 7.8 volts. Now, what I meant to say is, I wanted to remind you that the AC current here where I live is not 220, but more something like 235 volts. Okay, so let's turn it up a bit more, say to 150. There you go. This is 150, and now we're measuring almost 10 volts. Now, the output voltage for which this transformer is rated is 12 volts. And I think that it will go a bit higher at 235 volts AC. So I still don't see any smoke, or I don't see any sparks flying. So let's go up all the way now. Okay, I'm at maximum voltage on the variac, as you can tell. Okay, so we're at maximum voltage now. AC and DC, we're measuring 14.3 volts. DC current, okay, DC voltage, which is a bit much since the TV works on 12 volts and not 14, but I should remind you that there is also quite a heavy choke coil that will be connected to it. So, and that choke coil, of course, also has an internal resistance, by which I mean that the final output voltage of the power supply will probably drop by 1 or 2 volts, which is great because that's exactly what the circuitry needs, around about 12 volts. Okay, so the bridge rectifier checks out fine, so I'm going to connect it up now to the leads of the power supply. Then, okay, the bridge rectifier is hooked up and ready for use. So now I'm going to hook up the other parts of the TV. I want to give it a sort of a dry run, if that's the word to use. Now, the thing is, I need to mount the PCBs correctly, and if you look carefully at both PCBs, you'll notice something disturbing, which is that if you put them together like this, you see that the connector end of both PCBs matches almost perfectly. Well, in fact, they do match perfectly, front and back. Okay, so as you can tell, the traces match perfectly, which means that if you're not careful and you put them back into the chassis in the wrong order, so say I would put the IF board in the place of the video board, which is this one, yeah, I could very well, and in fact I'm almost certain, I would damage the boards irreparably. So you have to be really careful and know what you're doing. So that's one of the reasons why I always take a lot of reference pictures, just to be sure that I'm doing it correctly. Okay, so now the side you see of the TV, so in fact rather the orientation of the TV set, which you see right now, is upside down. So and it means that I would have to mount the IF board right here, okay, in this space, like this, and the CRT drive board on the opposite side, obviously. Now, it would be sufficient to put the board into its connector, and that's it. So I don't really need to screw it down, because the connector has its own ground connection. So for grounding purposes, I don't think I need to screw it down. So now what I'll do is I'll connect up the CRT, which is here. I think you can see it now. Yeah. I'll connect up the CRT to its base connector, which is this little one here, and of course to the high voltage connector, so the anode connector, and all the wires for the deflection coil, which are these 4 wires in fact. So the red, the blue, the yellow striped red, and the green. I'm not sure whether the green one is striped, but I don't think so. And of course there are a few more wires, like these wires here, which also need to be connected up. I can't tell immediately what these wires do, but I'll look it up on the schematic. So, yes, well, give me a moment to set it all up. I connected up the IF board, as you can tell, and it seems that the IF board is connected up to the high voltage cage, which you see here, via this shielded cable. Now, okay, I'll admit I still don't know exactly what it is, but I think it has something to do with synchronization. I'll take a peek at the schematic in a moment, and I'll tell you exactly what it is. Now, there are several cables connected up to the IF board. Well, several. I mean 2. This one here, okay, and this one there. Now this leads to the sound connector, okay, which is up here, right? So I'm pretty certain this is the sound output. This, on the other hand, is, I think, a video synchronization signal carrying cable, but I'll check in a moment. Anyway, here is the high voltage cage, and I wrapped it up in a plastic bag because I obviously don't want it to make contact with the IF board, and more specifically with the traces on the IF board. I think it's far enough of the IF board, but I can always move it a little bit more away like this. Now the problem is, of course, I need to mount the video control board, and space, as you can well guess, is at a premium in this chassis. So I'm sort of trying to figure out how to place the whole thing so that there are no false contacts and everything works as it should. So it's quite possible that I'll remount the high voltage cage or the high voltage box to the chassis first. I connected up the socket of the CRT over there, and I just simply reversed the whole chassis, so now it's the right way up, and I found out that experimentally, I should say, that mounting back the high voltage box inside the chassis to its correct spot would be the easiest way to go ahead. So what I'm going to do now is I'm going to mount back the CRT drive board, and do a last checkup to see whether I connected everything correctly. Okay, so I connected up all the wiring for the video. So the order is red, black, blue, white, and then yellow, but I mean the simple yellow. The yellow and red cable, which is this one actually, goes to the complete opposite side, so here, or wait a minute, okay, to this pin. Okay, so the yellow and red cable, this one, goes to this pin, and the green cable, which is this one, goes to that pin. Actually, how do I know that? Well, because on the PCB is marked a Y and a G. And the other ones, well, there are also symbols marked on the board, but I also took reference pictures, okay? Now, one thing I noticed immediately when I wanted to mount the board into its socket is that you can mount the board either this way, well, you can try, but the cables will never let you, or the other way around, which is the correct way. So that's another disadvantage really of symmetrical connectors. That is that you can easily confuse one direction for the other. Okay, so that too is a good reason to take enough reference pictures. Now I can only connect the green and the red and yellow striped cable to the PCB once it's mounted, or nearly so, in its connector, because I have to reverse the board completely like this to be able to hook up the green and the yellow red striped one. Now once I hooked up the cables, I can slide in the PCB into its connector. So let's just do that. Okay, I think you have a good view of it. So here we go. Let me see, yellow is here. Okay. Right. So let me check, yes. And then green, the green goes into this connector. Okay, so now that is correctly placed. Now I can slide the print board back into its connector. So I place it correctly like this, and then I give it a gentle but firm push. There you go. Now it's hooked up. Now I need to make sure that all the cables are free floating and not making any sort of bad contact, but I think they are okay. Now for safety's sake, I'm going to put a piece of plastic between the board and the high voltage cage, just to be on the safe side. Okay, once I'm certain that everything works okay, I'll have a good look at how to hook it up. Now of course I need all the settings to be reachable. Okay, so these potentiometers will allow me to set the TV. Now you'll notice one little detail, which is that there are 4 holes in the chassis for the potentiometers, but if you look carefully you'll count 5 potentiometers. So in fact this one, once the PCB is in its correct position, is unreachable, and in fact the potentiometer has been sealed with some special lacquer into a very specific position. So I'll need to have a look what potentiometer precisely this is, and then we'll see what its function is. Okay, so anyway, I think I've got it all hooked up correctly. I'll give it a once over, and then we will connect the TV up to the AC, and we'll do that with this cable, okay, which is at the back, obviously. So well, let me just hook it up. And I also hooked up the TV to one multimeter, which will display the current running through it, and I hooked it up to the other multimeter, which is an analog one, to show the voltage running through it, so that I can keep an eye on both and be certain that I'm not overloading it or anything. Now, the whole setup is hooked up to my Variac, and you see it over there. So what I'll do is I'll turn up the Variac slowly, say from 0 to 50, from 50 to 100, 100 to 150, and then the full voltage. Obviously, if something goes wrong, I will switch down the whole thing by turning down the Variac again and by switching off the TV with its own on-off switch. So yes, well, I sincerely hope that I can make the TV work without blowing any fuses or blowing up the TV itself. I have not started up the TV yet since I started restoring it, so this is as much a first for me as it is for you. So well, okay, let's just do it. So let me check whether, okay, the connectors are all in. Let me power up the multimeter. Right, it's on the 20 amp position. So, but if 20 amp goes through the chassis, it'll blow up. So what I'm expecting is to see perhaps a peak of 2.5 amp, and then seeing it slowly go down to, oh, I don't know, maybe 1.5 amp. But we'll see, because I'm going to ramp up the AC power slowly, obviously. Okay, so well, let's do it. Okay, let me switch on the TV. Right. Okay. Alrighty, well, here we go. Turning up the voltage now. I'm not seeing a lot happen with my current meter. So is that positive? Is that negative? I don't know. But the meter says I'm at almost 50 volts. Let's say I'm at 40 volts. But there's nothing happening. No, there's nothing happening at all. Okay, well. Let's try by moving it up a few volts.
We started providing them with uniform, giving them some washing powders, training them for cleanliness.
Okay, I'm at
It's very easy to talk about children.
about 75 volts, say maybe 80 volts, and I still don't see any current being drawn. But I don't see any smoke, I don't see any sparks or anything, so I don't think there is any short, at least for now. So let's turn up the voltage even more. Okay, we're at about 110 volts AC, and now the current meter is registering 10 milliamps, which is really very low, but that doesn't necessarily mean there's a problem, but it is still low, so let's turn it up a bit more.
Many of the children had some small place where they could keep themselves comfortable, but many is like literally on roads.
Okay. 20 milliamps, that's really nothing. We're at almost 150 volts AC, and there's still nothing working. I'm not seeing any. No, I'm not seeing any grid pattern, but I can see a small light lighting up here. You see? Which is probably the light bulb which lights up the channel selector, which appears to be a neon light. Okay, so but still nothing's happening, and I can't see the filament glow. So well, let's just hope there's no problem with the TV set. So okay, we're at 200 volts, and now the amp meter says it's drawing around about 40 milliamps, which is still not a lot. But I can see the filament glow, so that's a good sign. Okay, so yes, the filament is glowing. So okay, let's turn up the voltage a bit more. I'm not smelling anything roasting or being burnt or anything. Okay, well, I'm almost at full voltage, AC that is, and I'm at 60 milliamps. Okay, let's see. Let's put all the pots at maximum. Aha, we do have something. We have a trace, but it's vertical. It's only the vertical trace, you see? So there's only a vertical trace, which means that there must be a problem with the vertical deflection. I mean, there's only a horizontal trace, but there's no vertical deflection. Okay, so it means that there is a problem with the vertical deflection. Okay, well, at least we know there's high voltage. More closely this part here. Yeah. And obviously I'm going to go upstream from the deflection yoke up into the circuitry. Now, the very first thing you encounter when you start from the deflection yoke is this part here. And as you can tell from this here, this is the vertical output. Okay, so this is the output for the vertical deflection. Now, as you can see here, there is a diode in series with a 2 microfarad capacitor, an electrolytic capacitor, which, by the way, I replaced a few days ago. So this is brand new and very unlikely to be bad. So I thought maybe the trouble would be here with those two parts. So I measured the resistor. I'll show it to you in a moment. And the resistor measured way too high. Okay, so the schematic says it should be 18 kilobytes, 18 kilo ohms, and it's actually more like 25 kilo ohms. So this is already way too high. And the diode you see here, which is, by the way, I looked it up, an IT22. I replaced this diode by a very common 1N4007, which should do the job of that IT22 diode which I replaced. You might wonder why I replaced the diode. Well, quite simply because if the diode is shorted, and it really looks like it might be shorted, then the power for the vertical deflection will be shorted over this diode and through this capacitor. So if this diode is bad, you get no voltage on the deflection yoke. So that's why I took no risks, and since the diode is placed in parallel with the 18K resistor, I thought why not replace it as well, since I am already replacing the resistor right next to it. Okay, so I replaced these two parts, and I'm going to put the print board back into the TV and check whether that did the trick or not. So let me show you now the parts that I took out. Okay, they are tiny, really tiny parts. Oh, and by the way, I replaced them, as I just said, by an 18K metal oxide resistor, which you see here, and a 1N4007 right next to it. So this one here. Okay, so the original parts are here. Okay, so this tiny resistor here, which is actually more like a 19K and not an 18K, and this diode, which is an IT22. I don't know if you can see or read the lettering on it, but it definitely says IT22. Let me see if I can show you. There. It's kind of hard to read, but I think you can. So this is an IT22, and this is a 19K resistor, or at least the color code says it is a 19K. So brown, white, orange. Okay, so I measured the resistor, obviously, and I'll show you what the true value was that I got. Okay, so here is the multimeter. Okay. So I'm going to show you the resistor, okay? Measure it up. Okay, I'm in the 200K range. So let's see. Well, there you go. 25.5 kilo ohms. Now, 25.5 kilo ohms for an 18K resistor, that's something like 30% overvalue, which is really way too much. Okay, so this is the diode I showed you. Okay, now let me show you. If I measure it in conduction, so the negative lead, the cathode to the negative lead, okay, let's see, and the positive to the anode of the diode, then we get this. Say 20K, 21K, which is a bit high, but okay. Now let's reverse the diode. There you go. If you reverse the diode, you get 35K. So let's face it, guys, I think this diode is more than likely dead. So, well, there you go. I replaced those two parts. Now let's put it all together again and see whether the TV will function correctly now. And okay, I got it all hooked up. So I'm going to switch on the TV now, and I'm going to do a very gradual power up. But I'm not going to wait in between. I'm just going to very, very gradually turn the power up. Okay, here we go. It's switched on. Now, let's see what the result will be. Here we go. Okay, we're at 50 volts now and still going up. $100 volts. $150 volts. $220 volts. Okay, I can see the filament glow, but strangely enough, the neon bulb is not lighting up. Okay, there might be something wrong here. Let's see. Okay, we're at full voltage. Well, I'm not seeing, the filament is glowing, but the neon bulb is not. So I'm not getting any kind of vertical deflection. Ah, there it is. Okay. Well, okay, replacing the diode and the resistor did not change the situation, obviously. There's still no vertical deflection. Okay, so that's not very good. Right, well, the only thing this tells us is that there's still high voltage. Oh, by the way, the neon bulb, which is used to light up the channel selector dial, finally started to function. Yes, I hear you. I know what you're going to say, and you'd be right. Why didn't I measure the yoke coil first? And well, believe it or not, I actually did. Only I did it after I replaced the parts. Now, if you look carefully at the schematic, you'll see up there that the vertical yoke is supposed to have a value of 43.5 ohms. So let's measure the yoke and see how much resistance it actually has. Okay, here we go. Alrighty. Now, I think you remember that the vertical yoke is connected up to the striped red and yellow wire and the green wire, which is attached to this pin over here. Okay, so let's measure the resistance of the yoke and have a look. Okay, I'm in the 200 ohms range, so let me put one end of the multimeter here and let's measure the other side of the yoke. Come on. Oh dear. This is weird. Okay. I'm getting very fluctuating values here. Okay, hang on. Okay, there you go. So the actual value of the vertical deflection coil is 42.9 ohms. 42.9 and according to the schematic it should be 43 and a half. I would say that's close enough.